Question 8 is about determining specific latent heat of vaporization. So remind yourself that there's an equation for specific latent heat, and that equation is Q equals M times L, where L is the latent heat. One more thing that you will need to remember is that because this is latent heat, it is for state change, so the temperature will remain constant. In this case. So here it says figure 9 shows some of the equipment used. So they've got the power supply, they've got a beaker, they've got water, and they've got heat. Now this heater is supplying energy to the water. You've been given power supply. Now I will need a value of energy supplied in order to work out the latent heat. So how am I going to work out the value of Q? For that, I will use equation P equals E over T, where E is basically equal to my Q. The question says this is the method that the student used. Put 50 centimeter cube of water in a beaker. Measure the mass of the beaker and water. Use a heater to boil the water and keep it boiling for 600 seconds. So this will give you the value of T. And if you know the value of power from here, you can multiply them two values to work out the value of E or Q. Then it says measure the mass of the beaker and water after 600 seconds. So I can say these two values can be used to determine the mass. So I can work out the mass from here. So the first part says what measuring instrument should be used to measure the volume of water. So to measure the volume of water to this value, we will generally use in-lab measuring cylinder. Next part says what is a hazard in the student's investigation. So first thing is we have to remind ourselves, what do we mean by word hazard here? So hazard is something that can cause harm. Something that can cause harm. Are they given us 4 options? Burns, it's not something that can harm. Boiling water. Boiling water is something that can cause harm because if it drops on you, it can burn your skin. Next part says the initial mass of the beaker and water was 0.08 kg. The final mass of the beaker and water was 0.71 kg. Now I can use these two values to find out the mass. I can say mass evaporated will be equal to 0.080 take away 0.071. If you put this in your calculator, you'll end up with an answer 0.009 kg. Next part now says, the question further says the energy transferred by the immersion heater as the water boiled was 2,200 joules. So this is the value of Q. It says calculate the specific latent heat of vaporization, which is L equals question mark of the water by the student's data. Give units. This is something important to keep in mind because it will carry 1 mark. It does say use the equation from the physics equation sheet. So I know the equation. It is Q equals M times L. I'll say the value of Q is 25200. M is 0.009 and L is not known. All I have to do is I'll divide both sides by 0.009. 0.009. This will cancel out, leaving me with L being equal to 2, 8, and 5, 0. Now it does ask us to work out the unit. So what am I doing? I'm dividing basically energy by mass. So the unit will be joules per kilogram. Next part says some thermal energy was transferred to the surroundings while the water was being heated. So this is very important information. What they're trying to say here is that Q recorded is more than Q supplied to water. Says explain how this affected the student's value for the specific latent heat of vaporization of water. So I'll recall my equation is Q equals M times L. If I make L my subject, I'll divide both sides by M. this is cancelled out. So basically L is equal to Q over M. So if this value, the recorded value, is more than the actual value, then this means the specific latent heat of vaporization based on student's result is an overestimate of the specific latent heat of vaporization. So I can say because Q recorded is more than Q actual, therefore L calculated is an overestimate. Now, next part says some of the water evaporated before its temperature reached 100 degrees Celsius. So now again, this statement is important for us. It tells us that the mass recorded is greater than the mass boiled at 100 degrees Celsius. Again, if I write down my equation, Q over M equals L, I copied this equation from here. So in this case, M has a value which is bigger than the actual value. So if my denominator value increases while the numerator stays the same, my value of L will decrease. So I can then say, because M recorded is greater than M actual, therefore L is an underestimate.